Hello, Algebra 1 students for Mr. Fry. This isn't due until Monday, I believe. Let me double check that. Algebra 1. Yeah, due on Monday. So this would be due on the 14th. Today is the 11th. Okay, so we're looking at the practice arithmetic sequences. I'm going to do the odd ones. Go ahead and do the even ones. If you make mistakes, learn from them, and you're making progress. Here we go. Describe the pattern in each sentence, then find the next two terms of the sequence. So, looking at this, you just take the difference between these 15 minus 11 minus 7. It's always going down 4. So each term, since it's going down, it's, negative 4. So it's going down 4, down 4, down 4. So if I just continue that, I have negative 5 and negative 9 as my next two terms. Taking a look at the third one, if I just find the difference between these, so I take 3 minus 1.5, or 4.5 minus 3, or 6 minus 1.5, each time I get a 1.5. Notice it's going up, so each term it's going up 1.5. So the next two terms would be 7.5 and 9. Number 5, each term is adding 9. From 1 plus 9 goes 10, 10 plus 9, 19, and so on. The next two terms would be 37 and 46. For the next section, tell whether the sequence is arithmetic. If it is, identify the common difference. So, all three of these are arithmetic. The common difference is 6 in this one. Common difference is 15, and the common difference is negative 12. Okay. An example that would not be, that one goes up 4. This one, let me see, goes 4. Oh, here's an example of not 1. Notice it goes up 4, and then it goes up 2, and then it goes up 2 again. So this would not be, so there's an example of not arithmetic. All right, for number 13, you budget $100 for parking each month, and each day you use the parking lot downtown, and it costs you $5. So write a rule to represent the amount of money left in your monthly budget as an arithmetic sequence, and how much money is left in your budget after you have used the downtown parking lot 11 times this month. Well, I use this, I just went to this, it's kind of, slope-intercept form would be y equals negative 5x plus 100, but, what I have here is y being how much money is left in your account, x is how many days or how many times it takes you, so if you did 0 times, you'd have 100 minus 0, you still have $100 in your account, right? So your y, how much is in your account, would be 100. If you did it once, 100 minus 5 times 1 is 5, you would have $95 in your account, right? Okay, so I use this formula and I use it to figure out how many 11 times 5 would be $55, so 100 minus that 55, you have left in your account 45. Moving on to some more odd ones. Find the 4th, 5th, and 13th term of the sequence described by each explicit formula. All you do is you're going to plug in a 4, plug in a 6, and plug in a 13 each time you use this formula. So I plugged in a 4 and I got 0. So 6 plus parentheses 4 minus 1 parentheses minus 2. By the way, if you want a quick and easy way to do this, on your calculator, if you plug it in like so, 6 plus parentheses, I used 4 first, minus 1, and then another parentheses. Make sure this is negative. You hit the negative button, not the minus button, because if you hit the minus button, it'll come back. Error. So this is a negative 2. And then I hit equals. That's how I got my 0. So now, to save you some time, just use the back button. Change that 4 change your 4 now to a 6. So just change that to a 6. Hit equals. It saves you a lot of time. So you don't have to type it all out. I would put in the 13 first, just you'll see why. Because when you plug in 13, that shifts this over, and then you have to change the rest of your equation in the calculator. So if you have a calculator like mine, and that saves you some time, hopefully that will work. Here's 17 and 19 when I substitute in 4, 6, and 13. You could check and make sure you're getting the same things, because I make mistakes too. All right, 21 and 23. Tell whether each sentence is arithmetic, justify your answer, and if the sequence is arithmetic, write a recursive and an explicit formula to represent it. Okay, that recursive formula is that AN stuff. So it's, you know, that your first term minus the number of terms, or times the number of terms, all that kind of stuff. So this is arithmetic, and each term is -6. So this -6 goes at the back of your recursive and explicit formulas. And then, you know, you have the basic recursive formula. The explicit is actually using these numbers. So your first term goes here, 22, plus that how many times -1 in parentheses, and then times -6, because it goes down 6 each time. Now, if you plug in 2 for the second term and you work this out, you'll get 16. Pretty cool. And if you plug in 3, you'll get 10. If you plug in 4, you'll get 4. All right. Here's your answer for number 23. Check it out. Notice that it's a +9 each time. That's why I have a +9 back here, and I have it times just a regular old 9. Okay, and I started with my explicit, my -18, the term that I first started with. All right, so 25, your answers could vary because it depends on where you start, your number you start. I started with 3, lucky number 3, and an arithmetic whose common difference is 18, so it goes down 18, so you just put that at the end. So you just have the regular formula. Start, it varies because you could pick any number for this one. 27, explain how you can determine if a sequence is arithmetic. Basically, my writing is sloppy, I know, but let me read it to you. If each term is either added or subtracted by the same amount to get each following term. So each consecutive, you might want to use consecutive instead. So each consecutive term is added or subtracted by the same amount. That would be an easier way to say it. Hopefully this helps. If you need more help, make sure you Zoom me.